If you look over the sideboard on Monday, the 8th of February, you guys will be able to divide monomial section 6.2, okay? So we focused on these different rules with exponents, these actually shortcuts in 6.1, and a lot of them dealt with multiplication, right? What to do when you're multiplying bases, what to do when you're multiplying exponents, that kind of stuff. So today we're going to look at the opposite side. Okay, we're going to look at when we divide. So rule number 4 is going to deal with dividing monomials. So dividing these things, so we have a to the mth and a to the nth. Notice how they're both a, right? It's the same base again. And what we end up doing is we subtract them. Now, what did we do when we multiplied? What did we do with the exponents? Added them. So what's the opposite of multiplication? What's the opposite of multiplication? Division. And what's the opposite of addition? Subtraction. So notice, when you do the opposite of multiplication, division, we're going to do the opposite of the addition, subtraction, okay? And once again, I'm going to have us explore this, okay? To kind of look at, how do we do this? What's that mean? How do we get this shortcut? So how we get there is, if you were to have a to the 6 over a squared, a to the 6 is secretly how many a's multiplying together?
6.
6 a's multiplying together, right? And a squared is how many a's multiplying together? 2. So we have 6 a's multiplying together on the top, and we have 2 a's multiplying together on the bottom. Now, flash back to another type of problem where you have like 6 over 2. We can simplify that, right? You don't have to write the 6 over 2 down, okay? But we could simplify that, right? What can we simplify both by? A 2, right? We could take 6 divided by 2 and 2 divided by 2 and get 3 over 1, or just 3, right? Okay. Here's the part in the middle that we actually just do in our head. Is say, is 6 really just 3 times 2? Yeah, and 2 is 2 times 1. So are these equivalent statements? Saying 6 over 2 is the same thing as 3 times 2 over 2 times 1? Okay, those are the same thing, just written differently. So what we end up doing is we say we have a 2 and a 2, so we divide them. What's 2 divided by 2? 1. So we replace both these with a 1, and so you have 3 times 1, which is 3, and then 1 times 1, which is 1, which just gives us 3. So that's the math that's secretly behind the scenes there. We just don't see that. But that's actually what happens. So here, with our a's, we have an a and an a. And so what's a divided by a? What's anything divided by itself? 1. Anything divided by itself is always 1. So that gets replaced with a 1 and a 1. Now, can we do that again?
I don't know. Can we?
Yeah, we have another a on the top and the bottom. 1 and 1. Can we do it again though? Why not? Because there's no more a's on the bottom, right? There's nothing on the bottom that we can do that's the same on the top. So how many a's do we have on the top now? 4. So that's really a to the 4th. 4 a's multiplied together is really a to the 4th. Now, do we need to put 1 times a to the 4th? No. And on the bottom, what do you secretly have?
1.
A 1, but do we need to put that? No. So really, the shortcut that gets us from here to here is that subtraction, where you were to do 6 minus 2 is 4. And that worked because we have the same base. So when you divide powers with the same base, subtract the exponents. Do you have any questions on that exploration of how that worked and that kind of stuff? Okay, we're going to practice this rule a bit. Enjoy that. All right, let's look at number 1. S to the 3rd divided by s squared. What are we going to do with those exponents? Subtract them, because the same base s, remember the base is the number or variable being raised to a power, is being divided. S is being divided. So we end up with s to the what? First. Do I even need to write a 1 there? No, I can just write s. And we assume it's to the first, and we're done. Now, if you wanted to, we could go the long way and write s times s over s times s and divide these out and say, okay, well, those all turn to 1s, and we're just left with the s. But we don't have to. That's what the rule is for, is it's to shortcut that. Questions on that at all? Alrighty. It does kind of look like a 5. Is that better? A little bit, maybe? Alrighty. Let's look at number 2. X to the 5th, y to the 3rd, z over x squared y. Ooh, what do we think we might do here? Okay, subtract what? The common ones. So are we going to do the x to the 5th and subtract it with the y to the 1st? No, because it's not the same variable. We're going to do the x with the x. So we end up with what minus what for the x's? 5 minus 2, so we get x to the 3rd. Now, what do we think we're going to do with the y's? Subtract, so it's going to be y to the 2nd, because it's 3 minus 1. Now, is there any z to subtract with on the bottom? No, so what do we think we do with it? Just leave it. Just rewrite it as z. Nothing happened with it. It's still there, though. Very good. Now, like the long version of that, though, okay, which you don't have to write out, would be 5x's. That's a lot. 3y's and a z over 2x's and a y. So you'd go through and we'd simplify x, one of the y's, and you notice you're left with x to the 3rd, y squared, and z. So it still works the long way if you ever forget the rule. You can still do that. But you don't have to, okay? When we get all these rules, sometimes they get confusing, okay? Especially if you don't use them all the time. So like when I got into some higher math and I didn't use these rules all the time, and if it had been a while since I had used one, I would sometimes actually write these out the long way, the exploration way we've been doing them, just to remember what the rule was. Because when I was like, oh wait, do I subtract or do I multiply here? And I was like, oh, which one was that again? I would do it the long way and then be like, oh, okay, yeah, that was the rule. Number 3, go ahead and do it on your own. When you have it or have questions. Literally everybody got this one correct. It ended up being b to the, everyone say it at once? 10th, very good. B to the 10th, okay? 14 minus 4 is 10. 59 divided by 7?
71. What?
59 divided by 71?
Yeah.
Oh, is that for like a test?
59 divided by 71.
Definitely not.
Wait,
0.83, so it'd be 83%. All right, continuing on. Here's rule number 5. Wow, my goodness, I don't have rule number 5 in here. Okay, here's what we're going to do. I'm going to write down rule number 5 by hand. We're going to do it together on this. So, rule number 5, power of a quotient. Voice off, voice off. Rule number 5, power of a quotient. Abby, thank you. Voice is off. The same thing I said a moment ago. A over b to the nth. We have division. Okay, hence the power of a quotient. Quotient is division. Is really a to the nth over b to the nth is what it says on there. It already says that on yours, so you don't have to write that part down. The exploration is going to be where we take a over b and we square the entire thing. A over b and we square the entire thing. All right, what's it mean to square something? You're multiplying it by itself. There's 2 of that thing multiplying together. So right now, in this case, we have 2 of what multiplying together? 2 of a over b, the entire thing. So it's really a over b times a over b. Now, when we multiply fractions, what do? How do we do that? What? Okay, you looked at cross simplify, but can we on this one? No, then what do we do now? Okay, that's for when you divide fractions. Yep, you keep, change, rearrange, or multiply by the reciprocal. You just multiply straight across. So you do the tops and the bottoms. What's a times a? A squared. What's b times b? B squared. So it ends up just being a squared over b squared. So what ended up happening in our shortcut route is we took this 2, and just like before when a 2 was outside the parentheses, we distributed it in. But this time, we didn't just do it to the top. Where else did we do it? To the bottom, okay? So, to find the power of a quotient, find the power of the numerator is your first blank. And find the power of the denominator is your second blank. So on your paper, The first blank is numerator, second blank is denominator. So to find the power of a quotient, find the power of the numerator and the power of the denominator. So it's really just kind of an expansion of our previous rule on rule number 3, I believe it was. Yes, rule number 3. It's just kind of an expansion on that. All right, does anyone still need this?
No.
All right, so let's look at the example problems for this, okay? So the example problem 1, where we had 2x to the 4th over 4, all being raised to the 3rd. What would we do? Courtney.
You take the 3 and you distribute everything, so you take 2 times the 1, and then, you can tell you how to do it?
Sure.
So it's going to be 2 to the 3rd, and then x to the 12th,
Okay.
and then on the bottom it's going to be 4 to the 3rd.
Very good, very good, okay? So we take the exponent times all the exponents. Okay, Courtney was very careful in explaining that to say we aren't going to take 2 times 3, we're not going to take 4 times 3. That gives us different answers. Okay, we're going to take the exponent that was secretly on in the 1. Questions on this so far? So that's our rule. Now at this point, have we done stuff like this before? Totally, okay? So what is 2 to the 3rd? 2 times 2 times 2. 8. If you need to write that out, that's perfectly fine. X to the 12th is x to the 12th. What's 4 to the 3rd? It is 64. 4 times 4 is 16. 16 times 4 is 64. So now we have 8x squared, 8x to the 12th, over 64. Can we simplify that at all? Does anything go into both 8 and 64? Yeah. 8 goes into both. So we get really 1x to the 12th, or just x to the 12th over 8. Now, could we have simplified right here in the blue, where we have 2 to the 3rd and 4 to the 3rd? Could we have done 2 and 4 and say, oh, it's like 1 to the 3rd and 2 to the 3rd? No, you actually can't because they're different bases. Are 2 and 4 the same base? No, they're not. So that'd be like the equivalent of having like an A and a B, or an X and a Y where they're different, okay? Okay, does that make sense? Okay. Now, what if I told you there was actually a shortcut on this problem? Another way we could do it. Okay, you guys ready for this?
No.
Okay. Let me know when you are.
I'm ready.
Okay, cool. So we have the same problem, 2x to the 4 over 4 to the 3rd. What's our first thing in our order of operations? Parentheses. Is there anything inside this parenthesis we could do before focusing on this exponent of 3? Could I simplify the 2 and the 4? What goes into both 2 and 4? 2. So this really becomes x to the 4th over 2 to the 3rd. Now, I distribute the exponent, and it becomes x to the 12th over 2 to the 3rd, which then becomes x to the 12th over 8. Do we get the same answer? Yeah, it is kind of cool, right? At least I think so, but I'm also a math nerd. So I don't always expect you guys to think it's cool. But you get the same answer. Now, which one of these do you guys maybe have a preference on? Does anyone have a preference on which way you would do it? Or anyone see an advantage to one way or the other?
Well, the bottom one's shorter. Maybe just to make sure the top one.
Okay, the bottom one's shorter, but what do you say about the top one?
The top one, like maybe just to make sure.
Okay. Okay, you could do the top one again, as well, maybe just to make sure you're doing it right. Okay.
The top one, like when you're putting the like learn and make sure you're doing it correctly.
Yeah. So maybe the top one you're learning it. Okay. Why do we say the bottom one's easier? Smaller numbers, right? The numbers don't never get as big. Okay. I would actually encourage you guys to always look to see if there's things you can simplify inside the parenthesis first. Now, will there always be things you can simplify? No. But when you can, you're going to avoid numbers getting big, like 8 and 64, or even bigger than 8 and 64. Okay? All right. Let's look at the next example problem. Okay? Where we have 5x to the 5th y over 6 squared. Now, if we check for that little, that quicker way we did it on this one, can we do it here? No, I just say no, and I agree. Because 5 and 6 can't simplify, and there's no x and y's to simplify as well. So what's our first step then? Distribute the exponent to all the exponents. So it's not 5 times 2, or not 6 times 2, but it's that 1 times the 2 that's secretly on those. So this becomes 5 to the second, x to the what? 10th, very good. Y to the what? Second. And 6 to the second, very good. So now we say, okay, well, we can still do more here. What more can we do?
X to the 5 times the 5 squared.
The 5 and square it, so 5 times 5, 5 times itself. And what is that, Jaden? 25. Oh, okay. Gets me every time. X to the 10th and y to the 12th, just stay the same. There's nothing we can do with those. Is there something we can do with 6 squared, though? Yeah, what is that? 36. Yeah, actually do the exponent. So we get 25 x to the 10th, or y to the 12th, over 36. And nothing goes into 25 and 36.
How did it become y to the 12?
It shouldn't have. I had a typo. Thank you. All right. Any questions? Any other questions they should ask?
Do you have any other questions?
I don't, but thank you for asking. All right, let's go down to rule number 6. Rule number 6, this is low-key my favorite rule. Okay, and I think it might be yours too. 0 exponents.
0.
So, a to the mth over a to the mth ends up being a to the 0. 0th? And we end up getting 1. Here's our exploration for it. Okay? Let's say we end up having a to the 5th over a to the 5th. Yeah. Yeah, write this under the exploration, please and thank you. So a to the 5th is secretly what? 5 a's of them, right? 5 a's? And same on the bottom, right? Now what can we do with each of those a's like we did previously?
Cross.
Yeah, we can simplify them out, divide them out, and they each become a what? A 1, right? And we notice we can actually do that 5 times, can't we? So what do we end up getting on the top? 1. What do we end up getting on the bottom? 1. Is that just 1 over 1 though? Yeah. I want you to write this part down as well. Start with a to the 5th over a to the 5th again. We just learned in our last rule, what can we do with those exponents because we're dividing the same base? Subtract. No, that was, I guess, 2 rules ago. I'm sorry. What's 5 minus 5? 0. So this is really a to the power of 0. Now, here's the thing. If we did the problem one way and we got an answer, and we did the problem another way and we got a different answer, but both those ways are mathematically accurate ways. So what that must mean is if you do it 2 different ways and get 2 answers, and both times our math was correct, that they're the same. They're actually the same. Anything to the power of 0 is 1. And the reason why is just up here. Because when you actually write it out and you were to divide it the long way, that's all it simplifies down to is 1. So, what was that?
Because you always say A has a secret 1.
Well, sure, that's actually not the reasoning, though, unfortunately. Yeah, I like that you're trying to make these connections, though.
Does your wife have red hair?
Yes. Any number raised to the 0 power is 1. Now, did that say most numbers raised to the 0 power? No, it said any. So what if I say, what about 5 to the power of 0? 1. What if I say 1,282.543 to the power of 0? 1. What if I say x to the 5th, y to the 3rd, z to the 4th, with like 126 in front of that, all being raised to the power of 0? 1. Literally, anytime anything is raised to the power of 0, it's 1.
Always 1.
It doesn't matter what it is. If it's raised to the power of 0, that specific thing is 1. Now, what if I were to take that same example and the 0 was just on the z? Then just the z turns to 1, right? Very good, Eli. So it's still just 126 x to the 5th, y to the 3rd. Okay? Elijah.
That was like a super hard test with like a bunch of like super long equations, but them all to be the power of like 0.
It'd be like psych.
Like 6
Like-
pages full of just zeros.
Yeah, when you get down to it at the end.
Tests stress me out because, like, Mr. Howard, at one point on the test, I got like D's 3 times in a row.
Oh, yeah.
And I was like, this cannot be right. But it was right. It was right. But, like, I was.
Yeah.
It was right, but
Yeah, I get asked questions like that every now and then, like if I ever do that on like my tests. Like, do you ever have tests where like you get the same answer multiple times in a row? And I'm like, yeah, and it's low-key hysterical to watch students stress about it. It's really funny. I'm not gonna lie.
you just see him stand there with your leg.
I will pick
I got a 100 on the test. Mine's like
Yeah,
I was not happy.
yeah,
Here's what I'll do though. Like, if I think that I'm picking a number, like a letter for too long, I'll just pick the next closest answer.
Yeah.
Because I'm like, there's no way.
Yeah.
I messed up
yeah.
somewhere. But then it ends up being like, can't be right.
Like I want to do a test sometime where it's like it's a pattern, like it's like A B C D C B A B C D C B A, and it just like goes diagonal the whole time. Because like you know how much that would mess with students. Oh my gosh, I'd make so much more money. All the raises from people crying. Yeah. Or just do like A C A. Oh, I really want to. Right? Oh man.
Then they know if they got one wrong.
No, but a pattern.
But what if it's a pattern with like one off?
I would be so mad.
Because then like you wonder if like you got off somewhere or like oh my gosh. Oh, it makes me so happy thinking about it. Yeah, Eli.
I wouldn't be right.
So what
I
you
wouldn't
do
be right.
is instead of just having like one off, you have A, B, C, D, A, C, A,
It would annoy me
and
so
then you go
bad.
A, B, C, D. That way if they keep following the pattern, then they're gonna mess up the whole row.
Yeah. Oh, it'd be so good. Just like get them off by one. All right, let's look at number 7. Our last rule for the day. Okay?
No, we still have this one.
Negative exponents. Our last rule for the day. Then we have some examples. So negative exponents.
Tom Brady has
No.
a ring for every day.
This is Black Hole Sun by Soundgarden.
Oh, I thought that was sick.
All right, a to the negative nth. Okay, a to the negative exponent is 1 over a to the nth. Here's our explanation of this one. Let's take a squared over a to the 5th. A squared is how many a's? 2 of them. A to the 5th is how many? 5. Now what can we do with those a's again?
Take them to one.
Yeah, simplify them and down to 1. So we end up getting 1 on the top. And what do we get on the bottom?
Like one.
A to the 3rd. It's 3 a's. So we get 1 over a to the 3rd. Now what happens here the other way mathematically, go and write this other side out too, a to the 2nd over a to the 5th again. We said we can subtract these exponents too, right? So what is 2 minus 5? So it's a to the negative 3rd. Now we're in the same kind of scenario we were in a moment ago, right? Where we got different answers, but both these methods are okay. We did the right thing. So that means they're actually the same as each other.
What the heck?
So when you have a negative exponent, you actually just put it on the bottom of the fraction. It's reciprocated. Yeah. Okay, here's my little tidbit about this. Y'all are teenagers, right?
Yeah, sure.
Okay, y'all are teenagers, okay? So, every now and then, are you guys always in the best mood?
No.
No, okay, I don't think anyone is ever, even myself, okay?
Actually,
Okay.
me, I am a lot.
Raquel, no, you are not.
Yeah, I don't believe that.
You're always angry when you fight with your brother.
Raquel, I think you're on caps lock right now.
When you guys were younger and your parents would yell at you, would you guys like close the door, like fight with the door, like yell at the door, like you'd be like, you'd be
Back
like,
in the hallway.
yell at the door, but not actually yell, just like.
Ellie's always just.
All right, voice off. All right, so sometimes you guys are in a negative mood, right? Would that be a fair thing to say? Okay, sometimes you're in a positive mood, sometimes you're in a negative mood. Now, does that change who you are as a person? No, okay? You're still, guys. Okay, you're still yourself. You're just a positive or negative version of yourself, right?
You're not yourself
Okay.
and you're hungry.
Okay? Okay, Snickers. So sometimes you're negative, And this a to the negative third is secretly over a 1 right now, right? Is that secretly over a 1? Okay. Now, sometimes, let's say you're at home, and you're with your parents, and you're upstairs. Okay? Let's say the house is 2 floors, okay? And you're upstairs with your parents. Now, sometimes being with your parents, can that put you in a negative
It's
every now and then?
horrible.
Okay, I'm not gonna tell them that. I'm not gonna tell them your answer, but can that happen sometimes?
Yes.
Yeah, right. It can happen to everyone. Okay, it really does. Okay. So no matter how much you love a person, sometimes being with them is gonna make you negative. It just happens. It's life. Okay, people are different. So maybe it's best for you to go downstairs and get some space, right? Sometimes you just need some space, and then are you better after getting some space?
No.
Okay. So you're negative and you're upstairs, so you go downstairs and you're positive. You're still the same you, but you're more positive now. So here, a to the negative third goes downstairs instead of being upstairs at the top of the fraction, and it's still a to the third, but instead of being negative, it's now positive. Nothing else changed though. Okay. Now let's say the converse of that, the other side of the coin here, so to speak, is if we had 1 over a to the negative third. Let's see that a to the negative third starts in the bottom. Well, sometimes you're downstairs, you're by yourself, and you're negative. You're just kind of lonely, and you just need some interaction. Okay? Well, so what do you do to become positive? Okay? You're still the same you, but to become positive, you go upstairs. Okay? And now you're positive because you have that social interaction, because we need that too. Okay, so there's both sides. Sometimes you need the space, so you go downstairs, get some space, you're positive. Sometimes you need the interaction, you're lonely. Okay, you go upstairs, now you're positive. You're still the same person either way, but you just need a change of scenery. Okay, when you're negative, okay, just staying negative and doing nothing different is not going to help you. But a change is what's going to make you positive. A change is what's going to help. So here, changing either from top to bottom or bottom to top, upstairs, downstairs, downstairs, upstairs, is what will make you positive. And just like you, okay, the negative exponents work the same way. That change in scenery, the change in environment, is what's going to help become positive or negative, okay? Elijah.
How do you determine like if you go upstairs or downstairs?
Great. Is wherever you're at. So, negative upstairs isn't working. Go down. Now you're happy. Well, you're negative downstairs? Well, go back upstairs then. Now, okay? You'll be happier up there. But if you're already positive, why would you change anything? You know, life's good there. Don't fix something that's not broken.
Because
okay?
you want to switch things up sometimes.
All right.
My mom does
In this case, in this environment, we won't though. Does that answer your question?
Yes.
All right.
What
Now,
if it's an intruder, Mr. Carlson? Where's the side? Is there a window over there? If there's a window right there, so you can have that side of it, or this side of it?
so if there's an intruder inside of the building, we would hide over in that corner by the green cupboard. So.
But like, if it's outside the building,
No, this glass is like extra reinforced, so it'd be like incredibly hard to break.
Close the blinds regardless.
Yeah.
No, I break the glass.
All right. So continuing on,
smash mode.
let's go to the next page. X to the negative fifth. Hey, there's a negative exponent. We don't want it to be negative though. So what do?
We flip it.
We send it downstairs. So this becomes what? 1 over x to the fifth. That's just our answer. We just leave it like that. There's nothing else we can do. And it's positive now. It's still the same x to the fifth, but it's positive.
But we always end up making a positive move, right?
Whenever you move it, yep, you make it positive. That's the change that happens.
Was your mom mean growing up?
Why would you ask me that?
Sometimes carrots, so maybe like.
She's not a normal Karen. Raquel.
Have you ever been negative, Mr. Cosmo? I've never seen you being mad or negative.
Yeah, I've definitely been negative before. Yeah, that's for darn
Does
sure.
it happen often?
Not incredibly often, no. I'd say probably less often than the average person. But it still happens because I'm still.
Negative 2 to 5 days a week.
But I would say like I'm still human, so I still definitely have those days.
But you
In those
choose to be
moments.
negative.
Yeah, it's sometimes it's tough to. Sometimes it's really tough to choose to be positive. Sometimes it is.
And then I yell
Yeah.
at the door like.
But all right, number 2. Abby, let's say forward. Okay, let's look at number 2. 1 over a to the negative second. We don't want it to be negative, so what do? Send it upstairs. Just becomes a squared. Now it's positive. It's happy. Have that change in environment. It's choosing to be positive. Choosing to be happy now. by changing something. Yeah, Raquel.
Can we put it under 1?
Yeah, if you want to put the a squared over 1, you definitely can. It's never going to be wrong to call something over 1. Another math teacher might have a slightly different preference on that and say, no, you just need to stop putting it over 1. But as far as I'm concerned, it's mathematically equivalent, and it's already simplified, so I'm okay with that. Did I answer your question?
Yes.
Okay, Gucci. Number 3, 4a squared to the 0, b to the 3rd. What's going on here, Eli?
The 0, so it would make a squared turn to a 1.
Very good. So the a squared and only the a squared becomes 1, because just the a squared is being raised to the power of 0. So this is like 4 times 1 times b to the 3rd. Now what do we do?
Then you times by 4.
Yeah, 4 times 1 is just...
I just cracked. Did you hear that?
Uh-uh.
Oh my goodness, I thought you were gonna die. Did you hear that?
So it becomes 4b to the 3rd.
Oh,
Okay.
I give up.
So it becomes 4b to the 3rd. Any questions on number 3 here?
Wait, how did it equal?
Last night I just
Because anything by
Because,
0 is...
yep, a squared to the power of 0. Yep, does that make more sense, Elijah? Awesome. Thanks, boys. All right, let's look at number 4.
I was like 7.
Negative 8a to the 5th, b to the 4th, c to the 3rd. All over 24, haha, a, b to the negative 2nd, c to the 5th. Now, we notice, do we have some negative exponents going on here?
Yes.
Okay, I don't like those negative exponents. Let's take care of those first and foremost. So, what's the only thing that has a negative exponent? The b on the bottom.
Yeah.
So, do you think we're going to move all of the stuff on the bottom? No, just the b. Everything else is happy down there. Just the b needs a change of environment. So, right now, in our first step, I'm just going to have us write everything's the same, except for I'm going to put this b to the negative 2nd as a b to the positive 2nd on the top. And it's no longer going to be on the bottom there.
What about the 8?
The 8? So the negative, is that a negative exponent or a negative coefficient? It's a negative coefficient, so that won't affect it. Yep, great question, Abby. So if it was an 8 to the negative anything, then we'd move it. But it's not, so we keep it there. Yep, great question. All right, so now from here, we go through, and we'll just go through variable or piece by piece here. So coefficients, and then we go through by the variables. Negative 8 and 24, haha. Does something go into both of those numbers?
About 8.
8 goes into both those numbers, right? We could choose a smaller number, but we'd be here longer. So, the top would become what?
-1.
Okay, so this becomes a negative 1, or just a negative if you want to call it that, over, not 8, but, 3. Does that sound correct to you guys? Okay. A to the 5th and a, what do we do with those? Subtract. Yep. And so it becomes a to the 4th. Now, guys, whenever we subtract, we're always going to put our result on the top. Okay. I know we're starting to do things top and bottom now, so we're always going to put our result on the top. Okay. Now, what do we do with those b's? The b to the 4th and b squared. We add them. Very good. So it becomes b to the 6. Now, c to the 3rd and c to the 5th, what's that become? C to the negative 2nd. Very good. Now, are we done yet then? No, we have to move that c down. Very good. Because there's a negative exponent. So this becomes negative a to the 4th, b to the 6th over 3c squared. Now are we done? Yeah. Questions on that? Now, as you guys get more comfortable, do you think it's possible to kind of combine these first couple steps? Sure. As you guys get more comfortable with that, I'm definitely okay with you doing some of this division and simplifying. At the same time, you move those negative exponents, okay? But once again, that's as you guys get comfortable. So it's not something you guys start with, but something as you get comfortable, okay? I'm a soccer coach, in case you didn't know, okay? And so, one of the things that, we do when we go through drills is lately we've been doing some ladder drills. Now, when we've been going through these ladder drills, okay, let me point out Emily and Sarah here. As you guys have been going through these ladder drills, do I say, hey, go as fast as you can through them right away? No, what do I say? Go slow at first and speed up once you get it, right? Okay, so the same kind of thing. So go at the pace you need to at first. So if you need to kind of slow down and just do them one step at a time, great, do that. Okay, then if after a while you're noticing, you know what, I can definitely do a couple of these really it seems like I can move the b to the negative second upstairs and do some of the simplifying. Great, do that. Okay. Question on that. Okay.
When are we gonna
So-
use this in real life?
Yeah. Great question. So, a couple different answers for that. Okay, you ready for them?
Yeah.
Okay. Do you actually want this question answered or no?
Yes.
Okay. Well, you gave me a look that you're like kind of maybe just
I'm
joking.
gonna assume never.
Okay, so it depends. So you might not, Josh might, Sarah might not, Ava might. I don't know. Sarah might, she might not. I don't know. You might not. I don't know.
I'm not.
So, I don't think we can guarantee that. So there are plenty of jobs that would use something like this. There are plenty of jobs that wouldn't. So jobs that would, let me think, some sort of anything where you do any of equations and formulas. So some sort of carpentry might do that. Architectural work might do that. A lot of different science stuff might do that. Let me think. What else? Definitely math teacher. That one's pretty obvious.
What about a kindergarten teacher?
A kindergarten teacher would at least need to know this to
No,
pass
no,
a
you
test
need it.
to be a kindergarten teacher at the very least.
Okay.
Would be the minimum.
I don't have to know it though.
You would need to know it to at least pass the test because there's a lot of people. So a lot of elementary teachers and a lot of kindergarten teachers are people going to try and be teachers. Like I went to college with a lot of people that fit in this category. Okay, there's a test you have to take to try and to get into teacher programs in colleges, and there's like reading, writing, and math on it. And if you don't pass all three, you can't get into the teacher classes, and then you can't get your teaching degree and go on and continue. So, and a lot of people get hung up on this test, and they get kind of stuck on this test, and so they end up taking it multiple times, paying a lot of money to take it multiple times, and all this stuff. And sometimes they end up having to just straight up change their major because they weren't able to pass it. So it is actually good to know at the very least for that if you're wanting to teach a lower level than like a lower grade than high school.
I'm just gonna stay at home now.
Yeah.
Good job.
Yeah. Would you have been a little wary of me teaching you guys math if I didn't? Yeah, I had a feeling that's why you asked.
No, because like
Yeah.
lawyer people sometimes have to take
The bar.
the bar like multiple times.
That's true. It used to be that they could only take it one time and that was it. So it was kind of an all or nothing thing. The bar is a legal exam. You have to pass it in order to practice law, aka be a lawyer. Eli, you had your hand raised. Okay. Hey guys, let's take a second look at number 4 here though. Actually, I want to show you guys maybe another approach. Hey, can we subtract 4 and negative 2 since we're dividing by b and b? Yeah, our rule says we can subtract that. So we could do 4 minus a negative 2. Now be careful what happens when you have those two. You end up adding it. So this becomes b to the 6. And what do we end up getting 2 steps later? B to the 6. So do we have to move that negative exponent upstairs if you catch that and you're okay doing those double negatives? No. But be careful. Okay? Be careful because if it would be easier for you to move this b squared upstairs and then multiply, aka add the exponents, then do that. But if you see this and you're like, oh, I'll subtract 4 minus negative 2 like we did in the orange and get b to the 6, go ahead and do that. Did that make sense to anybody?
No.
A few of us. Okay, those who made sense to, awesome. If you want to do that, great. If not, then don't do that or come in and talk to me later.
I'll say one.
Other thing. Notice the C's. Where were there more C's at originally, the top or the bottom? The bottom. And where did the C's end up? At the end, they ended up at the bottom because there are more at the bottom. Okay? That's going to be a recurring theme, okay? Because if we were to end up going through and simplifying the long way and doing C times C times C times C times C over C times C times C, you'd end up reducing and ended up getting... Oh, I did it the wrong way. Oh my goodness.
This song's so good. It's Party in the USA by Miley Cyrus.
Yes. You'd end up having C squared on the bottom. Thank you. You'd end up having C squared on the bottom at the end anyway. No. Oh, I haven't put any Taylor Swift on this playlist. I should do that for you guys. You guys would probably like that. All right. Let's look at number 5. 5x to the 4th, y squared, all being raised to the power of 0. Jack, what do you get?
1.
Nailed it. Those are my favorite problems. Does it make sense why that's my favorite rule now? Yeah, because it's just 1. There is no work. We're done. That's awesome. Okay. On 6. 4p to the negative second, to the negative second, 3p to the third, to the second. Now, we see this negative exponent, and I encouraged us before to move this downstairs. But, is there something else happening that's going to change this negative exponent? Yeah, it's going to make it a positive when we distribute in that negative 2. Okay, so that's where we're going to start, is we're going to distribute in this negative 2 to the exponents. So it becomes 4 to the what? Negative second. P to the 4th, because we multiply those exponents. Negative 2 times negative 2 is positive 4. Now on the bottom, what do we do with this exponent of 2? Distribute that to the exponents as well. Very good, Courtney. So we end up getting 3 to the second and p to the 6. Very good. Are we done yet? The 3 and the what? The 3 squared. And can we do 3 squared? Yeah, we can do 3 squared. What else do we have to do? We have to do the 4 to the negative second. What do we have to do with that? Move it downstairs, okay? I'd probably do that first and call this p to the 4th over 4 squared, 3 squared, or if we want to do that now, we could, over p to the 6. Now, can we simplify those p's? P to the 4th and over p to the 6? Yeah, what do we do with those? You subtract. And so we get p to the negative second, 4 minus 6. Over, what is 4 squared? I'm not talking about the game 4 square, but 4 squared, squaring 4. 16 times 9, aka 3 squared. Questions on where we're at so far? Alrighty. I'm going to move over here now. P to the negative second, what am I doing with that? Moving it downstairs. 16 times 9, do we know off the top of our head?
Yes.
Chances are low. 16 times 9, what's 9 times 6? 54. 9 times 1?
9.
9 plus 5? 144. 1 over 144 p squared.
I think big numbers should be banished. Numbers over 100 are done.
Okay, your bank account's never going to get over 100 again. P to the 4th over p to the 6. Where are there more p's at, the top or the bottom? The bottom. How many more p's were on the bottom than the top?
I love that.
2. What do we end up having? A p to the second on the bottom. Are we noticing a pattern there maybe? Okay, cool.
Dots connect.
Sarah's making fun
All right.
of my lifestyle.
Any questions on number 6? It's not your lifestyle. It's what you stated that you might want to do. Let's look at any question on number 6 before we move on. Okay, our last example today. Okay, number 7. Okay. Have you guys ever seen Hot Rod? Anyone else you have? Okay. Alice, let's see if you remember this part.
What is that called?
Ultimate punch. Anyway, okay, Alice knows. Okay, watch Hot Rod, you'll get it. It's an amazing moment in a hysterical movie. Anyway,
You should watch National Lampoon's
I've only seen the Christmas one. All right, number 7. We got a lot of negative exponents going on here.
Let's switch up.
Let's just move them around. That would be my first step. I'm with Abby there. Let's just make all the exponents positive. Let's work from there, okay? So let's just go piece by piece and say what's moving, what's staying. So far, is the 4 staying or moving? It's staying. The p to the negative second, is that moving or staying? It's moving, okay. So we're going to end up with a 2 on the bottom, and then we're going to have a p squared on the bottom. So I did the 4 and the 2, did the p to the negative second. Let's now focus on the p to the negative first. Is that moving or staying? P to the negative first on the bottom. Is that moving or staying? Moving to the top, p, or p to the first. Now I'm going to go on to my q's. So I did my coefficients. The 4 and the 2 stayed. I did my p's. They both moved. Now I'm doing my q's. Q to the second, is that moving or staying? Staying. Q to the negative fourth, is that moving or staying? Moving to the top. R to the negative third, moving or staying? Moving to the bottom. R to the first, moving or staying? Moving. All right, is everything positive now? Yeah, we might like that more. Okay. We can divide the 4 and 2. What's that become? 2 over 1, right? So a 2 on the top. We don't have to put anything on the bottom. All right. P's. P over P squared. What happens with those? P to the, subtract and becomes P to the negative first. Where are we going to end up having this P at? The down low on the bottom, right? We'll know that. Okay. Q's. Q to the second, Q to the fourth. What do we do with those? Not subtract them. Add them because they're multiplying. Becomes Q to the 6. What do we do with the R? R over R to the third. Okay, R to the negative second. And where's that going to end up at? Bottom. We know that. So now we just have to move things around, right? So what's staying, what's moving? Okay, the P of the negative first is moving to the bottom. And the R is moving to the bottom. But the Q and the 2 to the Q to the 6 and the 2 are staying put. So we end up getting 2Q to the 6 over PR squared. Now, Isaac, I have a feeling that you are probably one of the people that would look at this and say, okay, if you were to do it from the orange step on, you'd say, well, there's one more P on the bottom than the top, so I'm going to put a P to the first and the bottom. Am I correct in saying that you probably did that, Isaac? All right. Okay. So I was saying the P over P squared. Would you just call that P to the first on the bottom there? So if you want to do that, if you're comfortable doing that, go ahead and do that. Okay? Or if you say, well, there's going to be 2 more R's on the bottom and the top, go ahead and do that. You're fine to do that. But just be careful you're not going to make a mistake, okay? Is all I ask. Does that make sense? All right.